Hi, this slideshow is to give you a description of how conceptual physics is set up and the student demographic for the course. The general demographic, most students that have taken this class are either juniors or seniors. Typically, they're those types of students that have trouble with math, that might struggle in algebra, students that need a lot of repetition to understand a topic, so a reinforcement of the physics topics. And also students that are in conceptual physics are those that might struggle with a rigor of a faster paced physics course. We do expect students to keep an organized notebook and use it as a resource. Students will receive hard copies of handouts and notes. They should supplement them with their own notes as we work through lectures and activities. The instructor is going to focus on demonstrations, specifically direct versus indirect physics relationships, and how to apply the equations. So not necessarily deriving equations, but when to use which type. We do use scaffolding to understand physics topics. So through the lecture, we work together as a group. The instructor does interact with the students. Then we'll build off of that, where students will pair up in groups of either 2 or 3 and work together. And last but not least, the students will get a chance individually to demonstrate their own knowledge of the topic. We do expect a lot of interaction, so students should be contributors during lectures, not just passive. They will have to work out problems on the board in front of the class, so they should feel comfortable with sharing their ideas or thought processes to the instructor as well as their peers. And they should be expected to work in groups and be active group members. Everyone's going to bring something to the table. For labs, it's a little bit different than maybe some other physics courses. As the material presents itself, that's what will determine when a lab will be performed. Sometimes we'll do labs during a chapter in the middle. Sometimes we'll introduce a topic with a lab, and sometimes we'll reinforce a topic or extend a topic and do the lab at the very end of the chapter. Some of the skills students are expected to learn is how to set up the technology, the equipment, the simulation software, so they will have a skill set associated with the physics labs. These are topics of study. The traditional mechanics with physics. We'll start off with scientific method, so some of probably what they discussed in chemistry. Then we'll move on to how fast does something move? Is it speeding up? Is it slowing down? How far did it travel? Vectors and scalars are a major topic in physics, so we'll compare and contrast those. Then we'll move on to collisions, different types of collisions, forces that work during collisions, energy, work, and power, machines and simple machines and efficiency. And after we finish up some of the major ideas associated with mechanics, we move into electricity and magnetism, which is our electrostatics, that is static charge, protons, electrons, neutrons, electric circuits, batteries, voltage, current, resistors, and then we'll piggyback off of that with magnetics. Now, as time allows, we will do some special projects or some other topics. It just really depends on the pacing of the course for that year. If you are enrolled in conceptual physics, you should expect to keep an organized notebook. We'll use these as a valuable resource as we work through assessments. You also want to be competent and comfortable with presenting your ideas and thought processes to a group. Additionally, you should enjoy being an active participant in your learning experience, so you should be a stakeholder and taking responsibility for your own learning. And you should also want to explain the world around you using physics. From conversations with students who have taken the course, the most important tools they said that you can bring to class are enthusiasm and a willingness to share your thoughts. And most students have said you will learn a lot, but you have to be willing to contribute. Thanks.